Hi folks, and welcome back to Physics with Captain Rod. I'm making this video to help you out with your Unit 2 homework here. We're going to talk about numbers 1, 2, and 3. Oh, I'm sorry, Unit 3 homework for you, 109 students. Okay, so number 1 here, let's see. How much work does a supermarket checkout attendant do to a can of soup if he pushes it 0.76 meters with a force of 4.7 newtons? So this is just a basic calculation. You just have to know how to calculate work. Right, so work is force times distance, and the force is given in the problem, and so is the distance, and calculate a value. Now, unit-wise, if you take your force in newtons and your distance in meter, that's what the units work out to, the newton meter. And 1 newton meter has its own little pet name. It's called a joule. And I think that, yeah, it's asking you to put the work in joules. All right, question B is to give the work in kilocalories. So a calorie is just another unit of energy. And what you want to do is, I'll have you do this and not do it for you. Look up the conversion factor between joules and kilocalories. Or you can look up between joules and calories, and a kilocalorie is just 1,000 calories. And then it's just a unit conversion problem. And again, just get a hold of me if you're having trouble with it. All right, next on the list here. Get rid of this. All right, so let's see. Number 2, an 88 kilogram person climbs stairs, gaining 2.8 meters in height. Find the work done to accomplish this task. Well, first of all, so a little bit, like work. Where's this coming from, basically? Oh boy, is that a crummy picture of a person, but so in order to go up the stairs, and again, I'm not describing it perfectly, but this will be good enough, basically. A force is applied to the person's feet, and ultimately that force is kind of transferred through the body, and then the person moves. As they move upward, there's your distance. That's a kind of a lax description of what's going on, but I think it's at least good enough to move on here with this problem. So again, work is force times distance, and the force is going to basically be equal to the weight of the person. So we can actually calculate that by mg times d, because mg is how the gravitational force or a person's weight is calculated. And that's about all there is to that problem, so that'll probably get us through that. Okay, number 3, calculate the work done on a 1,600 kilogram elevator car after it's lifted 39.5 meters at constant speed, assuming an average frictional force of 150 newtons. All right, so that one's going to take a little more thinking about here. Whoops. So let's say here's our elevator. Kind of crummy elevator right now. And there's some sort of force that's upward, pulling the elevator up. And as the elevator moves, there's 2 forces that are downward. The weight of the elevator, which we usually call mg, and it says something about a frictional force as well. Now, if the elevator is moving up, the frictional force on the elevator is going to be down. So I'm going to go ahead and put what's called a force vector for that, equal to 150 newtons. Now, as usual, by the way, your folks' numbers could be different than the ones that I'm reading off. Now, this is moving at constant speed. So what that means is the net force is equal to 0. And that means that this one minus these 2, 150 newtons minus mg, all right, is equal to 0. So they gave you a mass and they gave you the gravitational acceleration, and then you can calculate this force. And you're going to get a number. It'll come out in newtons. Then to calculate the work done, take this force times the distance given in the problem. And that should get your answer for part A. Okay, for part B, the work done by the gravitational force during this process. So that's asking for the work done specifically by this force right here. So I'll just leave this in red. So the work done by gravity here, right, is going to be the force is mg. And again, you're going to multiply by the distance. And there's also a subtle thing going on here, plus and minus signs. So work is considered positive when the force is in the direction of motion. So for example, here's an object. If it's moving this way, so let's imagine its velocity is in this direction. If you apply a force in this direction, the work would be considered positive. However, if the force is in the opposite direction, the work done is considered negative. So this object, as it's moving up, the magnitude of the work done, right, force times distance, where the force is equal to mg. But if the elevator is moving up, then the work done by this force is a negative number. And you're probably going to need the minus sign to get that right when you run it through the calculation here. All right, part C, when it says the total work done in joules on it, take your answer to the first work term that you calculated and add it to this. Now, when I say add, keep in mind that this is negative. So you'll have a positive number from part A and then minus a negative number for part B. All right, that should get you through those 3 problems. I hope that this is helping. Have a great day.